So today's experiment is an experiment that you have done it before. I remember it's experiment 5 in trimester 1. That's an acid-base titration. The difference is that in the experiment 5 you have done the qualitative aspect of it, where you have used an indicator. So the end of the titration, you know it by the change in the color, which was phenolphthalein, and it goes from colorless to pink. But today, we are going to study the quantitative aspect of it, where you will measure the pH at every point of the titration. So you will have to titrate 2 acids. The first one is a strong acid, hydrochloric acid, with a strong base, potassium hydroxide. And the second is acetic acid, which is a weak acid, or ethanoic acid, it's the same, with the same base, potassium hydroxide. Okay? You will collect data for both titrations, and then you have to answer questions. And the important part of answering these questions about this titration is to draw your titration curves. Okay? To start this, first you need to set up your experimental setup. So you have the support, the stir, your burette clamp, when you put your burette, make sure it's closed. Okay? Now the very first thing we want to do is to fill your burette with the base. So here we have the potassium hydroxide solution. It's a 50 milliliter burette, so you will need to take a little bit more, so like 60 to 65. Now when you add your base to the burette, make sure that you don't have air bubbles inside the burette, so add it gently. You fill your burette with the base. Now when you fill it, you fill a little bit more than 0. A little bit more than the 0 mark. And then you can just calibrate your burette to 0 level. Now you should remember that the meniscus of the bottom of the meniscus has to be at the 0, okay? Okay, excellent. So once you fill your burette, you need to take your acid, but before that, you need to finish the experimental setup. Now always manage to have the beaker in the center of the stirrer with your magnetic bar, and also manage to have the graduation of the burette toward you, and that the burette tip is inside your beaker. Make sure that your stirrer works. Okay? Now before adding the acid here, you have to set up your pH meter. Now this is the pH meter. To turn it on, all you need to do is hit power. It's already calibrated. Now this pH meter wouldn't work without the probe. So that's why you take the probe. It's fairly easy to connect it, okay? So now you can see that this solution here, it has a pH of 4.25 Okay, it's around 4.2. Now we need to take the probe out of the solution. So the tip of the probe is made out of glass, surrounded by plastic, so you have to be very careful when you handle it, okay? Now because the solution, the previous solution, it's not water or neutral, we need to wash it before we use it for our titration. Now, so you need to make sure that the magnetic bar doesn't touch the probe. And for that, you can use a clamp. So you can put your probe down as much as you can in a way that it doesn't touch your stirrer when you stir. Okay? Now, we'll collect our acid. We'll start first with the hydrochloric acid. So you will need 10 milliliter. Squeeze it up till like 15. Transfer it to the beaker. Now using the pipette, you collect exactly 10 milliliter of the strong acid. Now, 10 milliliter might not be enough to reach the probe of the pH meter. But as you know, for the titration, we use the number of mole, and adding water to the analyte doesn't change the number of mole, it changes the concentration. The probe is not touching the acid. Okay, you can either bring it down, which I will try to do it, and make sure that the magnetic bar doesn't hit it, or add some water, which is fine. Now, as you can see, you can read on the term on the pH meter, the pH is 3.3. Okay, so now you will need to wait some time for the pH to stabilize, and then record this data in your table on page 99. And this is when 0 milliliter of potassium hydroxide is added. Okay, once the value of the pH meter is stabilized, it's not fluctuating, you can start your titration. First start your stirrer. So now you can see that the pH is stabilized around 1.27. It's a strong acid. So now you start your stirrer. Make sure your magnetic bar doesn't touch the probe of the pH, and start adding your base. Okay, so 1 milliliter, and you record the value of the pH after adding each volume of the base. 2. 3, 4. Now, at the beginning, you will not notice big change in the pH because the pH is slightly increasing. Okay? Which I don't want to call it a buffer area since you cannot form a buffer solution with a strong acid. You will see it more with the weak acid. Okay? But now you can see that the pH starts to increase. So you have to add 22 milliliter of potassium hydroxide. So every time you add 1 milliliter, you wait for your pH to stabilize. Okay? And you can see that now it's increasing. Now if I leave it like that, what is the pH now?
8.
So it's going to stabilize. So you see the jump? Now this is expected because a strong acid, strong base, first the equivalence point is at pH equal 7. Second, the jump between the acidic pH and the basic pH is large. So even though you achieve the equivalence point, you continue further until that you add 22 milliliters. So as you can see, the pH is increasing because now, what is the major species in my solution? That's controlling the pH, the OH minus. Okay? So therefore the solution is okay? Now taking these values, you fill it in these tables, and later on you will be able to build your acid-base titration curve. You will do the first one for the acid, strong base. The second one, weak acid, strong base. Now remember, for the weak acid, you should observe the rapid increase in the pH, right? This is what we call hump. Okay? So once you have your data, as you can see, this is the titration curve between HCl and KOH. Now, you all know that the equivalence, the pH of the equivalence point for strong acid, strong base is 7. So from 7, you will extrapolate your data to get what? So from 7, you take vertical line, okay, until where it hits the curve. Then from the point that met the curve, you take another vertical line, and this is going to be your titration volume. So around 9.3, you evaluate this according to your graph. This volume, which is the equivalence equivalence point volume, you will use it to determine the concentration of the acid, knowing the concentration of the base, as you can see it here, 0.102. Now for the weak acid, it's different. Because what you have to do, you have to take a tangent to the bottom one, to the bottom part of the titration curve. So you take a tangent to it, something like that, okay? And then you take a parallel line to it, which is going to be something like that, okay? Then you take 90-degree lines from both sides, also 90 degrees, so they're going to be parallel to each other. Then from the middle of the first line, you connect it with the middle of the second line, okay? And this is going to be your equivalence point. Now, from this point, you project a horizontal line to the y-axis to determine the pH, okay, and vertical line to the x-axis to determine the volume at the equivalence point. And as you can see, they're almost the same, which means you should expect the value of concentrations of acetic acid and hydrochloric acid to be the same. I will leave this up to you for the calculation. But this is a very important step. Okay? So using these volumes, this volume here, you can calculate the concentration of your